This is SpaceX Starlink 2.8 launch coverage. And we'll switch over to science and tech. Yeah, I'm a beginner. I'm a beginner for KSP2 though. Yeah, just a putz, man. I thought this was SES 18 and 19. That is in 4 hours, believe it or not. SpaceX has double launches today. They have a launch from Slick 4 at Vandenberg, which is what this one is, and then another one from Slick 40 at the Cape in 4 hours. No joke. So we got to design all of our rockets and test them in that 4 hours so we can start doing the challenge, huh? I'm just going through tabs here. All right, there we go. Cool. All right. So, Mikey, you're a beginner to KSP and all this stuff in general. I just got my first rocket to a stable orbit. That's awesome, dude. Sweet. Good job, man. Feels good, doesn't it? That first time you circularize an orbit is an insanely good feeling. That is... Dude, I'm telling you. Is there a launch today? Ghost Mooner, there's 2, and we're the coverage for the first one should be starting momentarily here. No, you haven't missed the launch. We're waiting for SpaceX right now.
Discovery, go at throttle up.
Nemijer. Welcome to Mission Control. Your go at throttle up. Thank you for the Prime sub. I do appreciate it. Mitosi, you're wondering about Delta V numbers? What's on your mind, dude? I think the Delta V calculation in the VAB is off. Make sure that you have the stage that you're trying to get the Delta V from in the first stage in the VAB. Yeah, otherwise it is going to be off. Clang, EJ, do you think my curse will extend this far? Well, considering that we need to go to low Earth orbit, then do a free return around the moon, and then... What's the other ones in the challenge? And then do a landing on the moon. So we need to do Apollo 7, Apollo 8, and Apollo 11. Considering that, Clang, I actually want the missions to end in water, if that makes any sense. And then Duna as well. Yeah. I think that's a good idea for the challenge, dude. I think it's a good idea. You know, they say you don't have to... You could use whatever you want to recreate your favorite rocket, planet or fictional, go to Duna. You could do whatever you want, right? But I think it would be cool to do Apollo 7, Apollo 8, and Apollo 11, and then use the infrastructure that we used and do an Apollo applications program. So tackle going to Mars, or tackle how NASA was going to go to Mars with Apollo architecture. But, with Duna and Kerbin. I think that's a good idea. Thanks, it does feel pretty awesome. Mikey, wait till you put some down on the surface of the moon, dude. You're gonna feel like a freaking rock star. Hey, Seven. What I mean, EJ, is will SpaceX find water? I hope not, dude. The only time I want SpaceX stuff in the water is if it's a capsule. And I would hope for the same with the KSP challenge, dude. Build the Saturn 8? I think that would be good content for the stream, Yop, don't you? Question about Falcon Heavy. Do all 3 of first stages separate and return individually? Yes. They could. Somebody already said it in chat. Synerd already said it. So, Falcon Heavy center cores could land. The center core flies too far downrange to be able to turn all the way around and come back, Simus. So, if you had a Falcon Heavy scenario where you wanted to land all 3... SpaceX stream is up. If you had a Falcon Heavy scenario where you wanted to land all 3 cores, 2 of the cores would come back and land at the landing sites, right? And then the center core would land on the drone ship. And then the stage would go. But lately, they've been just expending the center core, which... that kind of sucks, but hey, it's all right. Hey, which rocket are you planning to send to Duna? Salyut, I think either using Saturn V architecture to make... Saturn V, Saturn 1 architecture to make a rocket like this. To make a rocket... To build architecture to go to Duna would be cool. But it also would be cool to make something like this. To build Nova. We might build Nova. I might just use multiple Saturn V launches. I'm not 100% sure. Hey, Pop, 41 months. That was a good question earlier, dude. Thanks for telling me. Or thanks for asking me. Excuse me. We're going to fast forward the SpaceX stream here. Need to create untitled spacecraft. I'm not sure if KSP2 will understand untitled spacecraft right now. Did you already run ads? We're 8 minutes out to launch as of the time of this post. I'll run the ads right now, Gene. So, fellas, I don't like running ads. I hate running ads. I try not to do it. It's really annoying and obnoxious. But, and I think it's terrible for streamer engagement. People got to make money though, right? Anyway, but I do run ads so people don't get them during the launch. Yeah, we run them here. We run them here right before the launch. Question with LZ1 and 2 out of operation for SpaceX now. Where will they land the boosters? Drone ships? I'm going to guess alleviate that most of them are going to be drone ships. And if they do RTLS one, it probably will land at 39A or Slick 40 or something. They'll probably just build a landing pad somewhere else. I personally think that, yeah, if they built one on Complex 40 or put one at 39A or something, I don't think that that's going to be a big deal. I think SpaceX is confident enough that they can stick the landing every time. And even if they don't stick the landing, I think they're confident enough that if something does happen with the rocket, it can divert away from critical infrastructure. I think that's why. So in the context of what we're talking about, dudes, SpaceX actually is Complex 13, where their landing pads are at the Cape. They gave them off to somebody else, to Viaspace. Another spaceflight company is leasing Complex 13 and using it to launch rockets. SpaceX giving up their landing pads at the Cape. Interesting, right?
Dragon, separation confirmed.
Hey, 1AU, 18-month resub. Thank you. Thoughts on doing the Vow Challenge or something like that? I don't know, Simon.
Landing like that deployed.
Maybe.
And Falcon 9 has landed.
I think, honestly, we'll be good enough having a Saturn V and a Saturn 1B, but that's just me.
Hello, everyone. My name is Jonathan Dweck, and I'm an operations engineer here at SpaceX. I'll be your host for today's Starlink mission, which marks SpaceX's 18th launch of the year and 217th overall mission to date. And today, we're sending another 52 Starlink satellites to orbit.
Reefer, have I ever been to the Museum of Flight in Seattle and seen the spacecraft displays? Reefer, I had the pleasure of going to the Museum of Flight with the developers for KSP2. Yeah. In 2019, I flew out there and got to go to the Museum of Flight with Nate and a bunch of other guys, which was actually really cool. Yeah, it's Vandenberg. Yep. There has been plenty of Vandenberg RTLSs. Yeah, absolutely. Yeah, Reefer, the Museum of Flight's baller. At the time, dude, they had the Apollo 11 capsule there. It was being shipped around as a tour for the 50th Apollo anniversary because 2019. And I had the pleasure of standing about a foot away from Columbia. Columbia was the Apollo 11 capsule, right? Yeah, I think it was. Yeah, they let the Kerbal developers and us get super close to the capsule. We couldn't touch it. Not that I would be too afraid to touch it. I'd be too afraid that I'd break something. With the conclusion of today, SpaceX will be under a launch every 4-day cadence.
Has also started to retract away from the vehicle.
So TE's moving back into the 87-degree retracted position. So a little bit of word on this launch here. I'll talk about it here. We got 3 minutes. So this is the 200. it's the 40th launch attempt for 2023. This is
Discovery,
SpaceX's
go throttle up.
222nd mission. SpaceX's 18th mission of 2023. This is Falcon 9's 212th mission and the 17th Falcon 9 mission of this year. The core that's flying today is booster 1071, which has been reused 7 times previously. And those fairings are reused as well, from what I can tell. The payloads are 52 Starlink satellites going to, these are polar Starlink satellites. So yeah, Starlink satellites that are going to low Earth orbit with a high 90-degree inclination. Yost, 12-month resub. Thanks, buddy. Are these V1 or V2 sats? I'm not 100% sure on that one, Synerd. Beef Farmer, your grandpa was a lead engineer at Vandenberg. Well, CF Braun, but he designed the launch pads and silos there for nukes. I have tons of materials that are marked top secret, all the engineering stuff. Oh, Beef Farmer, that's cool, man. You know, I don't talk about it too much, but I love missile silo design. It's so cool. It's taking all the complication of this and putting it in the ground. It's a really hard problem to solve. Think about when the rocket fires, guys. Where's all that fire going if you just have a silo? That's a hard problem to figure out. You got to find a place for all those gases to go. And the thing is, your integration building is also the launch pad. That's a hell of a systems engineering challenge, dude. That's really cool, Beat. Thanks for telling me that. That's neat. If there's any Titan 2 stuff in there, let me know, because I love Titan 2 silos. They're so cool. And you can buy them if you have enough money. I don't have enough money, but you could.
2, locks load complete.
And there you heard it as well. Falcon 9 is now fully loaded with 1 million pounds of fuel and liquid oxygen. And we're getting some venting there from our transporter erector as we just prepare for launch.
What they're doing there with venting the TE is this structure right here has the fuel lines, which are those two. See, there's 2 hoses right there? That's the fuel lines, fuel and oxidizer lines for the second stage. You don't want fuel on the launch pad or in the launch pad when you go to launch the rocket, because the fuel and oxidizer being so close to each other, they can light on fire. And you don't want your pad to light on fire when you go to launch the rocket. Not, you know, if you can help it. That's why they're venting down the transporter erector. They're venting down the liquid oxygen line. And they're pumping nitrogen through the line, and that ends up displacing all the liquid oxygen, which turns to gaseous oxygen when it hits that vent.
Sit back and watch as the Falcon 9 takes our 52 Starlink satellites into space.
It vapes, yeah. That's what I'm trying to tell you.
T-minus 30 seconds.
Yeah, Felix, right? No, you have to scavenge it, alleviate, with the purge flame. 20 seconds. Here we go. First launch of the day. Good. Our first catch of the day.
15 seconds. T-minus 10, 9, 8, 7, 6, 5,
Sound suppressor is
4, 3, 2, 1.
Green flash.
Engines full power. And lift off of Starlink 2-8. Go Falcon, go Starlink.
Oh yeah, look, that caught on fire a little bit. Did you see that? That LOX umbilical caught on fire a little ways because it sprayed all the liquid oxygen out. But that was a good ignition, good launch thus far. Everything looks real good there. Yeah, S, look, there's LZ4. There's the landing pad at Vandenberg.
At T plus 30 seconds, Falcon 9 has successfully lifted off from Vandenberg's Space Launch Complex 4 East at 12:26 p.m. Pacific Time.
Cool.
This is our 5th launch from Vandenberg just this year.
Dude.
Power and telemetry nominal.
I remember a time where someone launching 5 times in a year,
Falcon 9 is supersonic.
let alone a couple of months,
With
was
that
a
call
big
out,
deal.
Falcon 9 is now traveling faster than the speed of sound.
Are humans inside this? Nope. Satellites. Starlink satellites. Yeah, if anybody launched anything 5 times
Max
a year,
Q.
that was a big deal.
And there you heard that call out for Max Q. This means that the vehicle is currently experiencing the greatest amount of external stresses as it ascends through Earth's atmosphere on its way to space.
SpaceX has launched, this is their 18th mission of the year. 18, and it's only March. 18 times in 1 year is a big deal. 18 times in 3 months is like, yikes, what are you doing? What a shot, dude. Look at that.
And we're just about 1 minute away from a series of events MECO, stage sep, SES1, and fairing separation. MECO, or main engine cutoff, is where all 9 of the
I'm not
Merlin
sure.
1D engines on the first stage shut down.
They're
Stage separation is when the first and second stages separate.
15
SES1, or
seconds.
second engine start one, is where we light the single Merlin vacuum
checking.
engine on the second stage. And fairing separation is when those 2 fairing halves separate and fall away from the second stage. Keep an eye out for those events because they're
Trajectory is nominal.
going to be happening in rather quick succession.
Yeah, if you notice, the flame is slightly asymmetric, which means that Falcon 9 is actually it's actually boosting radial out. And then as they get close to staging, Falcon 9 will actually turn more in line with the way that it's going. The reason why it burns slightly off axis there is to push the apogee higher so the satellites can use less of their own thrusters to get into their final orbit. They're squeezing just a little bit more performance out of the stage that way.
MECO.
Stage separation confirmed.
Okay, SEP confirmed. We're looking up the business end here. Green flash.
And back ignition.
Merlin vacuum engine ignition looked good. Stand by for the fairing separation and click.
Fairing separation confirmed.
Here we go.
And there you
Pretty
have those
textbook at this
events.
point.
Again, that was MECO.
I cannot stress how complicated staging and then the fairing going right after that. That's a complex sequence of events that happens fairly quickly. SpaceX makes this look like it's not a big deal. It makes it look like they're going down to the grocery store to get a freaking gallon of milk. That's not that. What just happened there is not an easy thing to do. Staging is one of the most difficult parts of flying the rocket. Yep, you see the Channel Islands down there. You see the Catalina wine mixers down there. They must be great at KSP. Bro, they're so good at KSP, they're good at HSP. Look at how good they are at human space program. Human space program is difficult.
Currently, the
There's
first
no
stage is
reloading.
on its way back to Earth towards our drone ship. Of course, I
Difficulty
Still Love You,
settings
which
are,
is
like,
positioned in
way
the
up
Pacific
here.
Ocean. And a reminder, our first stage is on the left-hand side of your screen.
Okay, everything's going good here.
If successful with today's landing attempt, this will mark our 179th overall landing of an orbital class rocket.
You told Sid to come
The
down
MVAC
here and
engine
learn
on the right
KSP.
side
I saw that thread, yeah.
Stage is continuing its burn, and this should last for another several minutes here.
Yeah, they're playing hardcore, Alleviate. I tried to play Kerbal this way. We saw how that ended. Showed how difficult it actually is, right? Or it showed at least a window into how difficult this actually is. Yeah, dude, look at that. Solid 60 frames in human space program, bros. Simulation is great. You could have a million
As
part
I mentioned
ship.
earlier,
No
today's
slowdown,
Starlink mission
no
marks
frame rate
SpaceX's
lag.
217th mission overall and 18th mission just this year.
Yeah, Steven, there's no quick saving or quick loading in human space program. HSP is harder than Kerbal. Way more difficult. Planet's a lot bigger, need more delta V to get into
Both
orbit.
vehicles continue to follow nominal trajectories.
I love how this analogy actually makes sense.
And there you heard that
Anyway.
stage 1 and stage 2 are both following nominal trajectories.
What was that on the left video? So that's solid nitrogen that comes out of the thrusters, high vis. This little nubbin thingamajigger right there, that is a ACS. It's a cold gas thruster.
As a reminder, Starlink is a satellite internet constellation.
So that thruster right there is keeping the stage. It's moving the stage to the right attitude for when the stage starts experiencing what's called the EI, or entry interface, that the business end of the first stage is pointed in the right direction. Because you think about it right now, that first stage is up 120 kilometers that way. That's what is that, 73 miles up? That's a long way. There's not enough air up there to perturb the booster, so the grid fins aren't going to really do what you want. So they have compressed nitrogen up at the top. It's in the interstage. It's actually right next to the nozzle on the second stage when they, before it separates, right? And they have nitrogen thrusters right there that are just outgassing, well, nitrogen. The nitrogen thrusters here, when that gas hits the vacuum, right? When it hits the vacuum is the absence of heat. So all the energy goes out of that gas. And when all the energy leaves really, really quickly, you get phase change. So the thing goes from a gas to a liquid to a solid in like a fraction of a second because all the heat is leaving because you're in the vacuum, right? And then when you get to absolute zero, it basically, by the time you get there, it basically solidifies. The gas will solidify. So if you see like chunks of solid oxygen getting hung up on the second stage right there, that's solid oxygen from the vent lines. And if you see like chunks of solid nitrogen coming out of the thrusters here, that's what's happening, right? So right there, what's happening there is the reason why they needed to point the business end of the booster at the atmosphere, because what they're doing there, Falcon 9 was up 70 miles up that way. That's a long way. That's enough to experience reentry heating at the speed that it's traveling at. But Falcon 9 has a trick up its sleeve. It doesn't have a heat shield, doesn't need tiles like the shuttle or anything like that. Doesn't need a heat shield like Dragon, because the engine exhaust is the heat shield. That's why they needed to point the business end of the rocket at entry interface. You need to fly business end first. Oh, see, some of the socks came off there. You need to fly business end first. The reason why you need to fly business end first is because the exhaust gases from the rocket actually push the reentry heating away. They push accumulated plasma away from the rocket, and they envelop Falcon 9 in a cool column of gas. That's basically its heat shield. It's called supersonic retropropulsion, and it's my favorite part of a Falcon 9 launch. So now that you're lower down in the atmosphere, right, you could start to see aerodynamic perturbations because the grid fins are like, right? Now the grid fins are going to start working. You don't necessarily need to use the attitude control system down here because the grid fins can steer you back to the drone ship. It's possible, Moist. I don't know for sure. Look, you can see some condensation of air off of the edge of the grid fin there. The landing ship should be behind the left grid fin. It's right there. See?
And
Grid
there's
fin,
that confirmation
give
that
it
the
that
stage
little
1
turn.
landing burn has begun in preparation for touchdown on our drone
Landing
ship.
burn on
Of
the
course,
first
I still love
stage.
you.
There's the
Just
drone
coming into
ship.
frame now on the left-hand side of your screen.
Now, as the rocket decelerates, it'll get to the point where the grid fins aren't doing anything, right? Because there's not enough air going through them, and then they'll stop, just like that.
Stage 1 landing leg deploy.
Landing legs deploy. Easy. Easy.
Stage 1 landing confirmed.
You see the purge down on the motors? What they do
Falcon
is
9
they
has
purge the engines
successfully
out.
landed on our drone ship. Of course, I still love you in the Pacific Ocean. This marks our 179th overall landing of an orbital class rocket, including F9 and Falcon Heavy missions.
So check this out. If you look down here, let me pause for a second. If you look down here, the engines do have residual propellant in them after they shut the engine off. And some of that propellant and liquid oxygen gets puked up on the drone ship deck. See that right there? So what they do is they use the ullage helium in the stage to pump helium through the engine to get all the liquid fuel and oxidizer out of the engine. The reason why you want to do that is because, well, liquid oxygen oxidizes things. It makes things rust really, really, really fast. Anyone that lives in the salt belt knows exactly what I'm talking about. Purging the engines out basically makes them so they can be reused. That's one of the big things. Getting all the propellant out of that motor. Or out of the three of the motors needed to be purged out from the entry and landing burns.
For those of you interested in watching more launch coverage, tune in for a double.
Go to T+438. Oh my gosh. All right, what's up? What's on your mind? 438. Let's take a look.
As I mentioned earlier, today's Starlink mission marks SpaceX's 217th mission overall and 18th.
That. It's solid nitrogen, guys. Solid nitrogen. It's exactly what I was trying to tell you about. It's solid nitrogen. It's gas that's been outgassed by the attitude control system. It's aliens. Is that what you wanted to hear? It's aliens, dudes.
And today's missions are
Yeah, I knew they existed, or we're being lied to, or something. I don't know. It's solid nitrogen that outgassed from these things. The way it propagates up in space is really weird. That's why it makes a ring, because the way the gas. So, okay, think about it like if somebody's vaping and they go and they blow a ring out. That. But instead of blowing the gas out in a ring because you're outgassing into the vacuum, it solidifies in a ring shape. It's the same exact thing when someone has like a vape or a cigarette and they're blowing rings. Same thing. It's that, but in space. But, I mean, aliens.
Throttle up.
Sure. That's why it's like a perfect ring, because these thrusters, when they outgas them, sometimes the nitrogen solidifies and it blows a perfect ring. That happens. Oh yeah. Do we know what cameras they're using? It's
Discovery,
proprietary,
go throttle
so they're using their own cameras.
My name is Jeff.
It's a space vape. We know that Falcon 9 vapes, dude. Look. Look at that. Look at that fat vape that it just ripped right there. See? There's your proof. You sure that's gas? It looks like a solid structure. Yeah, yeah, of course. Well, it's solid nitrogen, if you really want to know. It's an impressive vape, right? No, okay, so, Smoothie, I'm going to nerd out here for a second. So, yeah, that's solid, absolutely. It looks like ice, right? So, in the vacuum, right, when you take cold gas, so cold nitrogen gas, and you push it, you outgas into a vacuum like that, what's going to happen? This is 7th grade science class, right? So you're going to go through phase change. Everybody has liquid, solid gases, right? At least I hope everybody would know that, right? So you have liquid, solids, and gases. So you have a gas at cold temperature, right? And you're taking that gas, and even though the gas is at a cold temperature, it's not vacuum, all right? So what does a vacuum do? Well, vacuum, it sucks. That's what it does. It's mega vacuum. It's gone from suck to blow. No, that doesn't happen up in space. It's mostly just vacuum. So, okay. Basically, it's not that the vacuum is low temperature. Okay, this is a little thing to understand with spaceships. It's not that it's really cold up there. Everybody's like, oh, space is cold. That's not true. Space isn't cold. It isn't hot. It's nothing. It's nothing because there's nothing there. Hot implies there's matter there, right? That can absorb heat from something, right? So the same type of principle that if you took like a metal plate and you put it out on a table in the middle of a hot summer's day and the sun's beating on it, it's going to get hot, right? Because the metal can absorb the heat from the sun. There's nothing up there to absorb any heat. So anything that you put out in space, right, is going to go through, it actually will just stay hot if you have a metal plate in space. But if you're going to take gas and you outgas that into space, right? The gas is cold, but space is colder. It's not colder, it's the vacuum, right? So when you put that gas out in space, what's going to happen is the thruster, because it's circular shaped, it will blow a ring, right? It'll blow a ring, but that gas is immediately going to phase change because the vacuum is not cold, it's not hot, it's nothing. That heat, any heat that was in that gas, any energy that was in that gas in the form of heat, you know, it's a cold gas thruster, but even nitrogen at like 32 Fahrenheit or 0 C is still well above absolute zero. That's a 273 degrees Celsius temperature change, right? So that's carrying a lot of heat comparatively to the vacuum, right? So what's going to happen is the thruster will blow that ring, right? And the gas will immediately the heat will just leave. Any temperature or any heat that was inside of this thing will just leave because you're in the vacuum. It'll just spread out, right? And that the gas will immediately phase change, right? Because of the ideal gas law, right? PV equals nRT, right? So if it's colder, right? Colder and hotter gases, right? So it'll immediately phase change. It'll go from a gas to a liquid to a solid real quick. And in that time that it phase changes, that's like maybe a couple milliseconds because you're in vacuum. The heat leaves the gas so quickly that it freezes it. And it becomes solid, and then you get those nice rings. It's not the first Falcon 9 launch where we've seen that, dude. I've watched hundreds of these things. That happens all the time. Yeah, it's weird, right? It's blowing a ring. The thruster is blowing a ring because the thruster is a little rocket engine. It's got a nozzle, and the nozzle is ring-shaped. So when it outgasses, it outgasses in a ring. And sometimes the gas will just freeze like that, and you just see that. Or what happens is the gas will actually kind of stay on the outside of the thruster, and it'll kind of start freezing to it, and then they'll outgas the thruster, and it'll blow the ring off. That happens all the time, dude. Yeah. I know, everybody looks at them and say, what is that? Why is it snowing in space? It's not snow. Snow is frozen hydrogen, dihydrogen monoxide. That's what snow is. It's frozen water. Damn Canadian water, right? That's solid nitrogen. Now, keep in mind, a little more interesting thing here. Little interesting thing. Certain gases won't solidify in space. And that is a huge application in spaceflight. Certain gases won't solidify. Hydrogen will not solidify in space. Neither will helium. Right? The reason why is because every element has a point where it can be a liquid, a solid, or a gas, right? You could have metallic hydrogen, or you could have solid hydrogen if you really tried. But here's the thing. The window for hydrogen to solidify is so ridiculously close to absolute zero that you're going to need to like do that in a lab, because that's not going to occur in nature. No way. But it can happen. You can have solid hydrogen. People have done that. I don't know what the hell you're going to do with it, but right? Hey, thanks, Zion. Yeah. All rocket science is just it's like the application of practical physics at its purest. You know what I mean? Like, and a lot of this stuff is really easy to understand. It's the doing rocket science part that's the hard part. Rocket science is easy to understand. No problem. Doing it is the hard part. That's why I can teach people about rockets and I can teach people how they work, but you don't see me going and trying to build a rocket. I would lose a hand that way. Yeah, the launch is done. Mm-hmm. Solid, so like helium is like hydrogen's distant cousin in terms of elements, right? Helium won't solidify either, because the window for helium to be a solid is so close to 0 Kelvin or absolute zero or nothing that it's not going to happen. That's not going to happen. Now, oxygen, on the other hand, oxygen will solidify at 197 C, I think. And the solid oxygen that you're seeing on the motor, on the second stage, is from them venting the motor. Now, why would you vent the second stage engine? What do you mean venting the motor? So what happens here? See that stuff? That's solid oxygen. Oxygen has oxygen solidification point is much higher than hydrogen or helium. Same with nitrogen, right? So what happens is when they stage the rocket, right? You know, let's back up a little bit. This is looking up the business end of the rocket. Right? So see these vent lines right here? In order to get the rocket engine to start correctly, you need to start pumping the propellants in. You'll hear that call in emission as MVAC chilling, or starting MVAC chill or something like that. It's basically when the computers pressurize, the computers are taking the pressure from Falcon 9's second stage fuel and oxidizer tank. The tanks are pressurized. They use helium to keep them pressurized because you need to use gas to force the liquid into the rocket engine, because you're fighting against gravity up there, especially during staging. And this is why staging is difficult, all right? Because think about it. In order for the rocket engine to work, it needs to work. Your rocket engine needs to be down here. And a first stage, for instance, has gravity pushing on the liquid fuel and oxidizer, so it's really easy to get oxygen and liquid oxygen and kerosene into the engine, right? Second stage, you're not accelerating. There's no accelerated forces because you're technically free falling right now. If the second stage separated and it never fired, it would be on a hell of a free fall for trajectory, and it would basically be weightless until it hits the water, right? You know, because you're basically falling. And all orbit is just falling around Earth, right? Just on a side note. So when you go to stage, you have to find a way to get the propellants to go into the motor. So what they do is, what SpaceX does is, and pretty much everyone does this, first of all. What SpaceX does is they start moving the propellants into the engine. They do it while the rocket is under acceleration, so they can use the accelerated forces of the rocket to saturate the engine, to prime it, basically. And they use some of the ullage tank pressure in the second stage. That way, when they actually go to stage this thing, there's 4 huge pneumatic rods on the first stage that push the stage away from the first stage and put that stage under a slight acceleration. So when the second stage starts, it'll start siphoning the fuel out of the second stage, but it's under a slight acceleration, so the propellants settle on the bottom of the fuel tank. Now, why is that solid oxygen why does it get deposited right here? Well, When they stage, those same vent lines, like you're going to start pumping propellants into the rocket engine. You obviously don't want it to fire when it's sitting on top of the first stage. Some rockets do that. Soyuz fires its second stage engine while it's still attached to solve that same problem of settling the propellants, believe it or not. The reason why you want to do that here is, you don't want the second stage to fire inside of the inner stage. So those propellants that you're trickling into the engine, they have to go somewhere. So they go overboard on vent lines. See these vent lines right here? Those are saturating the components, the fuel delivery components of the second stage motor, the fuel pumps. They're basically putting all of the liquid oxygen and kerosene inside of there, and these vent lines are where that propellant that's circulated through the system goes before you start the rocket engine. So, why is all that crap there on the gas generator recirculation manifold? It's there because when these lines depress, all that stuff splooshes out all over the place. Watch. You can see it happening in real time. See? See the vent lines? And when the vent lines go, right? When the stage gets under acceleration, if one of these, that piece coming off is normal. That's just to prevent harmonic vibrations on the second stage nozzle during ascent. That little ring thing that came off. So when the second stage goes, those lines depress, and when they depress, it's the same exact phenomenon as the attitude control thruster. And when they depress out, you can see one of the vent lines is open because it's open cycle right there. While the engine is firing, it still vents stuff a little bit, and all that solid oxygen builds up on it. And because the vehicle's accelerating, it gets to a point where that solid oxygen can't hang on anymore, and it does exactly what happens with the thruster here. It eventually falls, but when it falls and gets caught by the manifold right there. See? You shouldn't say 0 Kelvin, Kimbap. And yeah, there's not a pure vacuum. Pure vacuums don't really occur in nature. There's still crap floating around up there in space in the vacuum, but the vacuum is really close to absolute zero. And it's important to call it absolute zero, and you don't necessarily call it 0 Kelvin. 0 Kelvin is not a temperature. That's nothing. That means nothing exists. There's nothing there. Now, don't get me wrong. Like I said, space is an imperfect place. If you read about it and you read about like what's going on up in space, it seems like it's empty. It's not empty. There's all kinds of crap up there. There's all types of radiation, coming from the sun. There's radiation coming from other galaxies. There's ice. There's bits of solid oxygen and nitrogen from other rockets. There's rocks. There's all kinds of crap up there. It's not as clean as we think it is. And there's a lot of our crap up there too, like old satellites, old stages, stuff like that. So yeah, you're never gonna get like a perfect vacuum up there. That doesn't exist. Like a perfect uniform nothing there doesn't happen a lot in nature. Like that's one of the reasons why I know, like, you see this, everybody says, oh, it's aliens. See, the thing about space is that if it was some construct that humans came up with, it's way too imperfect for us to come up with. You know what I mean? Like, aliens that's too convenient for me. Like, oh yeah, like the fact that space is such an imperfect place and it's such a hazard, like that tells me everything I need to know. Like that's my biggest proof. Like, yeah, that definitely exists. No human would come up with something that's intentionally super imperfect like this. Like the way that space is imperfect is not, that doesn't sound like something we would come up with. You know what I mean? Fermi gets more vindication every day. You're damn right, Nick. What if the moon is an alien ship? I'm pretty sure we figured out it's just a big rock, Drac. I'm pretty sure they figured that out 50 years ago when they went and grabbed pieces of it. If it's an alien spaceship, it's a spaceship architecture that we are not familiar with. But it's hollow. Partially. So is Earth. Well, you never see a cave? When you ever play Minecraft in real life and go spelunking? Yeah, of course. Part of the Earth's hollow. That happens. Lava tubes and stuff, man. That's what the aliens want you to think. Anyway. All right, I'm stopping this conversation. Let's get back into KSP. Now, don't forget, we got another SpaceX launch happening here very soon in about 3 hours. SES 18 and 19, Falcon 9's launching out of Cape Canaveral. It's 7:38 p.m. It's currently 4, so that gives us 3 hours and 38 minutes to work on our architecture in Kerbal for the new Kerbal Challenge. So that's what we're going to do. Isn't the moon a chunk of Earth? They think so, Corn. We're not like 100% sure. It's almost like we should go back and like find out. We'd know a lot more about the moon if we had a laboratory on the surface there for 50 years. I'm saying we should build a city on the moon. I'm sick of not living in the Jetsons' future. I want the Jetsons, please. Thank you very much. Okay. You ever watch a guy named BPS? I know Joe Reefer. Yeah, Joe Barnard. Yeah, dude, he's from my neck of the woods. I hung out with him a couple of times before he moved. Oh yeah, I know Joe. Joe's a good dude. Do you know Joe? You don't know Joe? All right, cool. Yeah, Joe's smart, dude. He taught himself rocket science too. Joe is he's a cinematographer by trade. That's why his videos are so damn good. It's true. He's a cinematographer by trade. Yeah. I hope you don't mind me lurking while I wait for Diablo Flora. I don't care. If I'm your background noise, whatever, dude. Thanks for lurking the stream. I appreciate it. Did you see Joe's collab with Mark Rober? Almost accidentally made a guided missile. Yeah, you got to be careful about that, Alleviate. Building something that's designed to, like building a rocket that's trying to propulsively land, you got to be careful with that. Because if you make it propulsively land accurately, that's when people start going, hey, it's your friend, the FBI. I know. Remember that one time where you made a guidance system that could be used for missiles? Yeah, you remember that one time? Yeah, don't do that. Yeah, they don't like they don't want you making guidance systems. Yeah, that's why I don't. That's part of the reason why I don't get into talking about guidance systems too much on stream. Like, I understand how they work, and I can teach the basics for it, like inertial navigation and stuff, because that's pretty straightforward, but I don't get into details about how they work because that's how you get people showing up at your house. Yep. That's happened to a couple of YouTubers, dude. I think that happened to Backyard Scientists, if I'm remembering right. What do you want to make as a guided missile? Yeah, you don't do that. Don't do that. Don't guidance systems and fuel delivery systems are stuff I try to keep a little bit abstract on purpose because I don't want people showing up at my house. Well, Bing Bong, anyone with sufficient knowledge should be able to figure it out at this point with our technology. Yeah, but I'm not going to be the one that purveys that. I don't feel like going to jail anytime soon, okay? I hadn't planned on that for my life goals, you know what I mean?